Dear student, hope you are staying safe. So I want to take you on physics today, and our topic is electrical energy. Now, you people have studied the forms of energy. So you recall that electrical energy is one of the forms of energy. Now, specific objective. At the end of the lesson, you should be able to define electric currents and state the appliances operated by electricity. Now, differentiate between conductor and insulator based on their nature. State the differences between direct current and alternating current. Then state the uses of ammeter and voltmeter. Now, electrical energy plays a major role in our daily life. You know, everything we do almost on daily basis, electrical energy must have an impact on it. So we say almost all equipment used by men operates with the help of electricity. For instance, in our homes, electrical energy is used to operate a lot of appliances like radio, television, electric cooker, refrigerator, air conditioner, water heater, and so on and so forth. There are many other appliances, the household appliances that are operated by electricity. Now we say in industry also electricity play a very major role because it is required to operate many industrial machines. These machines are used in industry for the production and all other industrial processes like cutting, heating, washing, painting, rolling, cracking. Most of those industrial processes are done by machine, and these machines are operated by electricity. Now let's look at the electron flow. We are starting with the fundamentals of electricity. Now you remember we said that atom is made up of central nucleus. The nucleus is located at the central part of the atom, and the electrons revolve around the nucleus. Now we say the electrons are held to the nucleus by a strong force. A strong force is holding the nucleus and the electrons apart because they always tend to attract each other, but this force will try to hold each of them apart. So now we say if in a material the electrons are held to the nucleus such that they will not be able to move freely by energy, then we now say that such material is called an insulator. So if the energy is applied to a material and that energy is not able to move the electron in that material, such materials are called insulator. You know, examples of insulator, we have rubber, plastic, wood, especially the dry wood. So, and many other materials, they are insulators. Now, we say on the other hand, if the energy supplied makes the electron free to move, then such materials are called conductors. So you know in insulator, the force is holding the electron in such a way that applied energy cannot move it. But in conductor, the applied energy is able to move the electrons. So, examples of conductor, we have metals. Metals like iron, aluminium, copper, and so on and so forth. We also have conductor like the liquids that are good conductors. Such liquid, we call them electrolytes, like salt solutions, like sodium chloride solution, copper 2 tetroxosulfate solution, even fruit juice, they are electrolytes. Also, something like metals, you know there are some metals that exist in liquid state, like mercury is also electrolyte. So they are good conductors of electricity. Okay, now we say now the motion of free electrons in a conductor is called electron flow, and this electron flow is what we call electric current, and that constitutes electricity. Okay, so we now define electric current as the flow of electron in an electric circuit. Okay, look at the diagram of an atom. So when you look at the atom, you see the nucleus is represented by this central part where we have the red and blue. While the red are the protons, then the blue are the neutrons. You know, the proton and neutron make up the nucleus of an atom. Then around the nucleus we have shells. Those shells, you see the electron revolving around the shells. Okay, so now we say electric current is defined as the flow of an electron in an electric circuit. The SI unit of electric current is in ampere and is denoted by capital letter A. And we say we have two types of electric current. Number one, we have the direct current and the alternating current. Okay, you listen. So we say if the flow of an electron is in one direction in a circuit, it is called direct current. So we call direct current as the current that flow only in one direction. So example of where we can get direct current is in touch batteries. Even the motor batteries are all sources of direct current. Now you also know that solar cells, the solar panel you use at homes, they are also sources of direct current. Even though the current produced is now later converted to alternating current in order to power our appliances. Okay, now we now say that if the direction of electron flow changes, then the current is called alternating current. So we call alternating current as the current that changes in direction with time. So example, alternating currents are obtained from generators and power generating companies, like the electricity you use at home from the discos. They are all alternating current. Also, the one obtained from generators. But you should know, we have also the generator we called the direct current generator, the DC generator. Okay, so you will learn that later. Okay, now circuit diagrams. You find out that we always represent the connection of the pathway of electric current flow in a diagram. So such diagram is is called what? The circuit diagram. We say a circuit diagram is a diagram representing the pathway of electric current when some electric components are connected together. In the electric current, electron flow is from the negative to the positive terminal, but the conventional electric current flows from the positive terminal to the negative terminal. Okay, let me explain this. In circuit diagram, we have is made up of the connection of the circuit components. Examples of such circuit components are the battery, the ammeter, the resistor, the voltmeter, the fuse, the switches. They are circuit components. When they are connected together in such a way that current can flow, we call it the circuit. So when we represent them in a diagram, we call it circuit diagram. You know, the battery has the positive terminal and the negative terminal. So that is why we say that electron flows from the negative terminal to the positive terminal, but the current flow in the other way around. So that means the current flows from the positive terminal to the negative terminal. So what you should understand here is that the direction of flow of electron is the opposite to that of the flow of current. Okay, now look at this current, this circuit diagram. Now when we come to the circuit diagram, we have two types of circuit. We have the open circuit and a closed circuit. For instance, this particular one is open circuit. An open circuit is the circuit in which the current has not started flowing because there is no complete connection in the pathway of the flow of current. So you see that here the switch or the key, we call it switch or the key, but this particular one here is represented by switch. This switch is open, therefore the current is not flowing, so we call such circuit open circuit. But in the next diagram, you watch that the switch is now closed such a way that the current can flow from the battery to the lamp. Therefore, it's now power on the lamp. So you see the lamp is on. So therefore, this circuit is called a closed circuit. So whenever we say open circuit, you know it is the circuit that is not complete as a result of what? The key or the switch being open. Why the closed circuit is complete? Because the switch is closed. Okay. Now look at the electric circuit showing those circuit components. You see the wire connected to the battery, then another wire connected from the battery to the switch, then from the switch to the bulb. So this represents the diagram we have shown before. So this is how it is represented. So this is what we call the circuit diagram. Now you look at the battery. You see that the battery has two terminals. The two terminals, the positive terminal and the negative terminal. You see the terminal that is represented with a longer line is the positive terminal, while the one represented with the short line is the negative terminal. Okay. Then we have the ammeter and voltmeter. These are two electrical instruments. Now, an ammeter is an electrical instrument used to measure the amount of current flowing in a circuit. So look at the two ammeters represented here. So they are used to measure the current flowing in the circuit. We said that ammeters are usually connected in series. They are usually connected in series in the circuit. So series connection we are going to discuss later. Now, the voltmeter. Look at the diagram of the voltmeter. We said the voltmeter is an electrical instrument used to measure the potential difference between two terminals in an electric circuit. So voltmeter, unlike ammeter, is usually connected in parallel across a load. So while ammeter is connected in series, the voltmeter is connected in parallel. Okay, now let us look at parallel and series circuit. You know we say voltmeter is connected in parallel, ammeter is connected in series. So what is parallel and series? Now, there are some electrical components like battery, resistors, even the lamp like bulbs. So when those electrical components are connected, for instance, the battery connected end to end. End to end means that the positive terminal is connected to the negative terminal of from one to another in such order. So we say that such components like battery, they are connected in series. For instance, in a torch, if you consider the torch, you see that the two batteries or three batteries in the torch are connected in series because one is connected to the other end to end. So you see the positive terminal of one is joined to the negative terminal of the other. They now form a series circuit. Now, why do we connect components in series? So you listen. The main purpose of series connection is to increase the total electromotive force. You know, I'm sure you have learned the meaning of electromotive force. We say the electromotive force is like the power of a cell or the power of a battery. We say it's the potential difference of a battery in an open circuit when it is not connected to any external circuit. Like if you bring a torch battery, you will always see the electromotive force, e.m.f, is of one torch battery is 1.5 volts. So that means if you have a torch that uses two batteries, that means the voltage that is supplied to the torch bulb is 3 volts. So we said that the main purpose is to increase the electromotive force. So in that torch, two batteries 1.5 volts each connected in series, we now have what? A total of 3 volts. If the battery is 4, we now have a total of 6 volts. So if they are 6, we have a total of 9 volts. If they are 8, we have a total of 12 volts, and so on and so forth. Then, in such series circuit, we find out that the same current is passing through. The current does not increase. What increases is only the potential, the electromotive force, but the current will always remain the same. So that is the purpose of series circuit. The purpose of connecting the electric component, any electrical component, whether it is resistor, whether it is bulb, whether it is cell, the purpose is to ensure that the e.m.f is increased while the current remain the same. Okay, now look at the circuit showing series connection, series circuit. So if you watch in the left hand side, you will see 3 bulbs. The 3 bulbs are connected in series from one end to another. Then when you look, you see in the right hand side, you see that the 2 batteries are connected in series. So you see the way they are connected end to end. So that is what we call the series circuit. Okay, now we look at the parallel circuit. We say when electrical components such as battery are connected side by side with positive terminal connected to another positive terminal and the negative terminal connected to another negative terminal, it is said to be in parallel. Here we call it side by side connection. So if you have two batteries, you connect the positive side of one battery to another positive side of the second battery and the negative side of the first one to the negative side of the second one. Such connection is called parallel connection. Now, why do we connect in parallel? Now, the main purpose of parallel connection, is to increase the total current and maintain the same electromotive force. So you see here, the current is increased while the EMF remain the same. Let me give you an example. For instance, house wiring. House wiring are usually connected in parallel because different appliances use different currents. So each appliance can draw the currents according to its capacity. But the potential difference that is applied to all of them will remain the same. So you see at home, the potential difference of all the appliances is 220 volts, which is the voltage of electrical supply for Nigeria. So whether it is air conditioner, whether it is refrigerator, whether it is your phone charger, no matter how big or small the appliance might be, they are all powered by 220 volts. The only thing now differ is that the phone battery will now use smaller current while the air conditioner will use a higher current. That is why they are all connected in parallel. So look at the parallel connection. So if you watch here, you see in the left hand side, you see the three bulbs, they are connected in parallel. So when you connect the bulbs in parallel, you see that all of them are going to, the brightness of all of them will be the same. But if it is in series, the brightness will not be the same, especially if the currents flowing through all of them are not the same. So if you would check in the right hand side, you see the two batteries connected in parallel also. So you see that the battery is going to supply a current that is very high to the bulb, but the potential difference will remain the same. Okay? Now, in summary, we say that the electric current is the flow of electron into an electric circuit. And we define conductor as the materials in which the energy applied can move the electron in them from one point to another, while the insulator are the material in which the energy applied cannot move the electrons in them. Now we also say that the electric current in a circuit is measured with an instrument called ammeter, while the potential difference or the voltage is measured with an instrument called the voltmeter. We say the ammeter is always connected in the series in the circuit, while the voltmeter is connected in parallel. We also say in electric circuit we have open and closed circuit. The open circuit is a circuit that is not complete because the switch is open, while the closed circuit is a circuit that is closed because the switch is closed. And we also say that the electric current is divided into alternating current and direct current. The direct current is the current that does not change in direction. It flows only in one direction, while the alternating current is the current that changes in direction with time. Okay, now the assignment. So you see the questions. Number 1, define electric current and state its SI unit. Number 2, state 3 domestic appliances operated by electricity. Number 3, you mention the difference between a conductor and an insulator and give 3 examples of each. So number 4, what is an ammeter and a voltmeter? And state how each of them is connected. Then number 5, give 2 examples where each of series and parallel circuits are used. Okay, so you submit the assignment in the Google Classroom. So thank you very much and stay safe.